So in this video, we'll go over how to configure Synergy Virtual Connect remote port monitoring. So the use case is, so if you have some network analyzer of your network switch, so Synergy can capture any server, internal server traffic and send it over to its dedicated uplink into your switch network. And from there, your switch network will have to configure its own span or R span to forward the traffic further into your network analyzer. So in that case, you will have a centralized, network analyzing workstation, instead of just directly attached to a single Synergy frame. Okay, so the pretty much again, we do have a corresponding local Synergy local port monitoring configuration video. It doesn't matter if it's local or remote. You need to go to one view, go into networking, go into the logical interconnect. From there, you click the actions, you click port monitoring, and over here you can choose, the remote or local. So you can only configure either mode. So if you have a remote mode monitoring enabled, you will not be able to configure any local port monitoring configuration. So for the remote monitoring, port monitoring, pretty much the sequence is you need to have the network dedicated for this remote monitoring. So let's go to the uh, networking, the networks. So this is pretty much you need to have a dedicated VLAN. So this VLAN will be internally inside the Synergy Virtual Connect domain. It will be encapsulate your original server traffic and send it over to Synergy uplink into your switch network. And from your switch network, then you will configure your local R span or ER span to forward the traffic further into your Wireshark or TCP dumb workstation. So this is coming back to the configuration. So first, you need to make sure you can uh, select the network name and uplink. So the only in this network, the any uplink under this network will be showing up here. So if you take a look at the logical interconnect, if we took a look at our original the uplink configuration, you can see I have a multiple uplinks, but for this one it's a span, and you will see I have this network defined under this uplink set, and if you take a look at the uplink port, it is a Q5 colon 3. So this is a 10 gig port going to my upstream switch, which is a ACI fabric for Cisco. So okay, so if you coming back, so pretty much this your Cisco span equivalent, the destination port, and from here you can select add port whatever server traffic you want to add. So in this case, I add server uh, in bay one for both modules, because for each server typically has two ports for one mass adapter. So one is A leg going to virtual connect in bay 3, another is the B port going to virtual connect in base 6 for redundancy. So I selected both ports, just want to make sure I can see all the traffic coming in and from this server. Okay, so you click OK, then, because we didn't change any configuration, I'll just cancel it out. So you can see this is a summary. So this is a summary. So that's how it's configured. So one thing to make sure is, this Q5 colon 3, it has to be dedicated just for the span and, traffic. You cannot have the user data traffic live running and running on the same, the uplink set. Okay, so this pretty much you need to consume one dedicated uplink and one network and one uplink set for this remote port monitoring session. Okay, so if you take a look at our ACI side, so ACI, the span is under the fabric access policy and the troubleshooting policy. So over here, you can see we pretty much define the I have a one HPE DL360 running Windows Wireshark, and then that IP address is 15, and so the tell the ACI, okay, I want to send the traffic to this destination with the source is from myself, as the for this EPG for this bridge domain layer 3 address. So the source you can see it's it matches with my destination, but you can see the incoming port. It's this leaf access leaf switches of this port. This port is connecting into this Q5:3. So that's from ACI or any Nexus Cisco switch or any other vendors. You take in the traffic from the Synergy uplink, then you do your own ER-span configuration. Okay, so pretty much that's the then you encapsulate inside your GRE header, send it out to your final Wireshark workstation, which is in my case it's about 15. So if you take a look at my configuration, I do have one EPG running, EPG VM1 IP11, the VLAN ID 2001. So let's do a ping verify. Okay, let me start this capturing for so this is 15. So let's do the continue. So we'll just wait monitor adding traffic going to 8.8.8.8. So let's do the ping 2, 3, 4. Okay, I'll stop here. So you can see I have about 8 packets for the echo and echo reply. So pretty much you can see the most important thing. You can see the traffic or read traffic is it's with a VMware DBS port group VLAN ID 2001. So you can see this is 789. So this is that the Synergy remote port monitoring span session. So we want to, so inside the Synergy we encapsulate. So let's go to this one, 789. So the traffic inside the Synergy will encapsulate into this one, and into the 789. So sometimes you will see this 802.180 ID2. This is more like our Synergy internal FlexNIC ID. So sometimes you will see it, sometimes you don't. It depends on where the Synergy internal capturing point. So you can just ignore this. This is really not your user traffic data. So pretty much this is your original data. This is the Synergy remote port monitoring, these dedicated VLAN ID, so we can wrap it up and send it out to our upstream switch using a dedicated link. And over here, you can see this is a GRE tunnel ER span. This is where the Cisco ACI, ER span for the ACI, configuration. And you can see this is whatever we config for the source and the destination. That's pretty much how you can see it. Okay. And one thing is sometimes you might need to open the I think it's there's a reference edit reference. In order to decode the GRE packet, sometimes you need to go to you can check the Cisco document, go to the protocol and type in letter E, go into the ER span section. You might need to enable force to decode fake ER span frame. So that will do the trick to enable the right display for the Cisco ER span GRE packets. Okay, so this is how you can see the packets from the original server encapsulated into HPE Synergy Virtual Connect remote virtual remote point monitoring VLAN header, and then going to the Cisco, and from Cisco they are doing the GRE span to the centralized Wireshark or TCP workstation. That's pretty much how you can do it. One more, the most important thing is you have to have a dedicated network to for this ER for this remote port monitoring session, and you also have a dedicated port and then the dedicated uplink. You cannot run any user data traffic over the same uplink set. Okay, this is very important. Okay, so if you want to configuring the local port monitoring session for the Synergy, you can check the other video. But this is more for the remote port monitoring session for HPE Synergy. That's it. Thank you very much.